remember that in the higher J, you also have, trying to draw a similar. For higher J, you have K0 star, K star plus, sorry, the star first, K star 0, and then rho minus, rho plus, and then you have pi, omega, and rho 0, and K star minus, K star 0 bar. So at high energy. Here rho 0 is just the same as the one pi 0 here, except that it has higher higher L equal to 1. Here L equal to 0, and here L equal to 1. So here is still rho 0 is still u bar minus d bar over root 2. So that's just normalization. Then you have the omega, which is just u bar plus d bar root 2, and finally pi. That is, pi is just, there are 3 particles here, 1, 2, 3. It's just the pure S bar. So how do you actually the detail of why you choose this one, because this is called a singlet. It's because you use a decomposition of 3 times 3 bar, get 8 plus 1. So this one is this singlet. The other 8 are the 6 outside and 2 inside. And of course, those are all for this group. You have the 3 quark and 3 anti-quark mixture. From shell model, okay, in the nucleus. What we learn from shell model, nucleus and this electron outside the atom. There is always a spin-orbit coupling. So spin-orbit coupling occur in the electron outside the nucleus, and this can be seen by if you apply a magnetic field. So the level of each electron, in this KLM, KLM, and so on, that will split into smaller levels if you have a spin-orbit coupling. And same with the nucleon, the nucleus. So the shell model, any shell model, must include spin-orbit coupling, otherwise you cannot get the right energy level. The shell model predict accurately the existence of, for example, magic number nuclei. Okay? So those are closed shell, so they are very, very stable. But without the spin-orbit coupling put, you cannot get also the other energy level. And then quark, same. Quark also 2, if it is quark and the quark, or 3, quark, quark, quark. And they are also spin-orbit coupling. Times some factor, and then the spin of quark dot spin of anti-quark. The bar is over the S, not over the dot. Divided by the mass quark, mass anti-quark. So this is the spin-orbit coupling. And they found that this to be correct. And similarly for the baryon, the mass of the baryon. Where did I find it? Yeah. The mass of the baryon will just be M1, M2, M3. So this is quark number 1, 2, 3, and then you have A dash. Okay. But then here you have many possible coupling between the spin of the quark S1 dot S2 divided by M1, M2. S1 dot S3 divided by M1, M3 plus S2 dot S3 divided by M2, M3. So this has been solved and found to be correct. Yeah, you can get an estimate of all those masses of the baryon and meson very accurately. Now, how about the interaction within the particle itself, between the quark? That one actually, we don't want to go into detail, but there is what you call the back model. Quark back model, whereby inside the particle, say a baryon, there are quark number 1, number 2, and number 3. 3 quark. So how do they interact between them? It's a 2 or 3 body problem. Very simple. Though the interaction are controlled by some potential. VR, and again this form minus quarter alpha S, where alpha S is a strong coupling constant, H bar C is just a dimensional number divided by R plus some F 0 R. They are far from each other, but and they are relatively free. For large R, I'm not saying how. Become stronger here. So for large R, attraction is small. Repulsion large. So meaning give the idea of what you call asymptotic freedom. But it can never be zero. Okay? Macam layang-layang, kamu lepaskan tali, dia rasa dia bebas. Tapi sebetulnya tali itu masih ada. Okay? So this give you the idea of asymptotic freedom. So what is important is that it can never be zero. So no quark can come out of the baryon. That now, of course, there are ideas about mass hierarchy. This is just idea about our mass hierarchy. You see, if mu mass of u quark equal to mass of down and this equal to mass of strange, then this is a U3 symmetry. In reality, the mass of U is roughly about mass of D and not equal to strain. The strain is the jump. So this means that U3 is broken. The unitary group is broken to U2 cross U1.